Hello, everybody. Feels a little weird here. It's night, and I'm in my room all alone in the dark, teaching to you, but it's a little strange. Anyways, we're doing bivariate data, two-variable data, and we've talked already about linear regression, which is what we're going to be leading up to and doing with that. So today we're going to be doing our notes. We have part A and part B. They should both be pretty short, and I'd like you to take good notes on that and look for any further assignments in your Canvas classroom. All right, so bivariate data indicates a relationship between variables. Okay, cases. All right, and this is good for later in the year. If I have two categorical values, then I would use a two-way table or something we learned at the very end of the course called a chi-squared test. And you may have been familiar with that from some of your science classes. If I have one categorical data and one numerical, then we use a two-way table. Okay, but we're interested right now is if we have two numerical variables, we're interested in linear regression, seeing if there's a linear model that will fit that, that scatter plot that we plot with this data, and if it's something that's reliable enough to where we can make predictions, we can discern different things and interpret it from our graph, if we have a strong linear relationship. Okay, and notice it's linear regression. There are other types of regression, but we're going to be working on linear regression in our class. Linear regression, what is it all about? Okay, it involves finding the line of best fit, okay, or other appropriate model. For us, it's usually the line of best fit, which formal name is the least squares regression line, okay, and we see it written as LSRL in the abbreviation, okay, and remember that is a precise, exact line. There's only one line of best fit. There's only one least squares regression line. That is a line where all the residuals, the differences from the actual and the model, the line that we draw, are the minimum, the lowest that we can possibly have. It's the best line there is. Okay, this is really important here, association versus correlation. An association is any connection or relationship between the variables. Two things can be strongly connected, but not in a linear pattern. They would have a strong association, but they might have very little correlation, which is our next term. Okay, so it's just a connection. Okay, and in everyday usage, when you hear it on the news, they'll talk about a correlation between this and that. They mean association. They're not using the statistical word properly. Okay, in statistics, correlation has a specific meaning. Okay, and it is a measure of the strength of a linear relationship. Okay. So measure of the linear strength and the direction. Remember, a positive correlation will mean it's heading uphill, and a negative will mean it's heading downhill. They can both be just as strong or weak. It's just up or downhill depending on what you're studying, and it has no pertinence to like the value of anything. It's not better or worse. Okay, so correlation, super important, the difference here. Correlation, a measure of the linear strength, okay? Association, just is there a connection between the two variables? If I know something about one, okay, then would I know something about the other? Okay, and I'll show you an example of that later in our notes today. All right, possible correlation values. They range from -1 to 1. -1 being perfect linear correlation or a perfect linear relationship, and I mean perfect. Every single dot of your data is exactly on the line, not one off. That's not perfect. -1 is ridiculously strong. It's the strongest it could possibly be. 0 means no linear pattern at all. They can't tell if it's going up, down, left, or right. It's just a blob usually. Okay, no relation at all. That's our worst. Okay, and then +1 being the same as -1, perfect correlation except heading in an uphill direction. Again, perfect correlation means that every point, every single point is exactly on the line. All of your real values match exactly with your predicted values. All right? Okay, association versus correlation again. Okay, this definitely has a pattern, whatever these two variables are. If I know whatever this one is over here, then I could predict that it's up there. It looks like it predict really well. Maybe it's a parabolic pattern, okay, with a different type of curve, but that is not a linear relationship. So this has very strong association, very weak correlation, if any, possibly 0, okay? Would that line of best fit be here, here, there? I don't think there is one that we can say. Excuse me a moment. I have to go over here for this. All right, here we are on the other hand with correlation. These two variables here, they have a strong association, okay? They're predictable, they're heading downhill, and they also have a very strong linear association. So this group here has high association and also high correlation. Again, these guys over here, there's a very strong association. That doesn't mean there's high correlation. Okay, there's a strong association, but linearness, no, it has probably a correlation of almost 0. Okay, it could be 0. All right, so very important you get this difference between the two of them there. All right, okay, these are our examples of correlation. Remember, they go from a value of like -1 through 0 all the way to +1, okay? This is my attempt. It's not actually perfect, but this looks like I'm attempting to draw a perfect correlation. Everyone is in there. It's perfect. It's heading uphill. The R value, that's my correlation coefficient R. That's my correlation coefficient, the number, the rating of the line. The linearness would be a +1 there. Okay? All right, this guy looks pretty moderate. I know it's going uphill. I can see that. Okay? But it's not nearly as good, and you might think it'd be like 0.5, like in the middle from 0 to 1. Okay, but it's probably much stronger than that. I'm going to call it a 0.7 or 0.75 maybe. When I look at them and I guess the correlation, I'm usually wrong in the low way. I usually guess too low, so it's usually higher than I think. So I'm going to say that's probably somewhere near a 0.75. Okay, it's got pretty good correlation. I can see if it points out here, I imagine it's up there. Okay, but they're not so linear. They're not on the line for sure. They're pretty close to the line though, and they're heading uphill, so it's positive. Okay, this one looks like I have no idea. If it points out here, I have no idea where it would be. Okay, I would say this is a correlation of 0, and I can't tell if it's going uphill or downhill. I can't tell anything. This guy is my attempt again at being perfectly linear, so it's exactly linear. It's perfect, but it's heading downhill this time. This would have not a slope, but a correlation of -1. And I want you to realize that the correlation and the slope, those are different things. A positive correlation just means uphill, and a negative means downhill. A correlation of 1 does not mean it goes up 1 and over 1. It has nothing to do with that. Okay? That would have -1. That's definitely not down 1 over 1. That's very steep. Okay? But downhill is negative, uphill is positive. Okay? And what we're thinking is as the x values get larger and larger, the y values are increasing. With a negative correlation, as the x values get larger and larger, the y values are decreasing. Okay? Okay, this is our rating system here. Okay, I put absolute value on there because if it's positive or negative, it doesn't matter. That's up or downhill. But if a correlation of a group of data is 1, it's perfect positive or negative correlation. Every point's on the line. We talked about that. Okay? All right, anything greater than 0.8. Okay, so 0.8 is debatable too. It depends on who you talk to. But 0.8, 0.82, 0.85, 0.97, all those are strong. Anything stronger than 0.8, okay, is considered strong positive negative correlation. Okay, less than 0.8 but greater than 0.5 would be considered moderate, either positive or negative correlation. You're always going to talk about the strength, that's the number value, and the direction of the correlation with the line. Okay, and lastly we have a correlation of less than 0.5. That would be weak. Positive or negative correlation again, that means that if I look at my points, they are not close to the line of best fit. They're all over the place. They're very far from it. So I can't use that line to do a good job predicting, okay? If I have a correlation of 1, my line is perfect and all the dots are on the line, I can make exact predictions. When the x increases, I know exactly where the y would be because they're on that line, okay? 0.8, they're close to the line. It doesn't mean any are on the line. It just means that the points that are generally pretty close to that line, there's a good linear pattern, okay? They're following that, either positive or negative. Again, in moderates, not as good, all the way down to 0.5 where it is weak, 0.5 and lower, okay? It says less than 0.5. Right on these edges, got this, it could go either way on that. All right, that is it for part 1. Thank you very much. Catch you in a minute.